Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue under chapter number 3, type 1 and type 2 error. So this still under hypothesis testing. So the possibility of drawing incorrect conclusion and inevitable byproduct of hypothesis testing is called type 1 or type 2 error. So no matter what sort of mathematical facet is laid is top of the decision making process, there is no way to guarantee that the test is going to be 100% correct, right? So there is a possibility of type 1 error and type 2 error. So the definition of type 1 error and type 2 error is, type 1 error is if null hypothesis is rejected when null hypothesis is true. We are rejecting null hypothesis when the null hypothesis is true. So this situation is called as type 1 error, right? Type 1 error is when the null hypothesis is rejected when null hypothesis is true, right? So we reject null hypothesis when the null hypothesis is true. So this is what we call as type 1 error. The symbol for type 1 error is alpha, and alpha is also called as the level of the test. And another type of error is type 2 error. We accept null hypothesis when null hypothesis is false. So this is another error, which is type 2 error. The symbol for type 2 error is beta, right? So this is the illustration for type 1 error and type 2 error. So this is our decision when we fail to reject null hypothesis or we accept null hypothesis, right? And the state of nature is when the null hypothesis is true, so we're making a correct decision. When the null hypothesis is false, right, and we accept null hypothesis, we are committing for type 2 error, right? So in another situation, when we reject null hypothesis, but the null hypothesis is false, is not correct, so we are making a correct decision, right? So when the null hypothesis is true, but we reject null hypothesis, this is what we call as type 1 error, right? So this is just an illustration for you to understand the definition of type 1 error and type 2 error, right? So type 2 error is denoted as beta and type 1 error is denoted as alpha. So the power of the test, right, is 1 minus beta. 1 minus beta is called as power of the test. And beta is the probability of type 2 error, right? So this is just a definition that you need to understand, right? So now, let's look at example number 1. So in example number 1, suppose that manufacturer A of a new medication want to test the null hypothesis theta equal to 0.9 against the alternative hypothesis theta equal to 0.6. So his statistic test X, the observed success, the observed number of success recovery in 20 trial. So he will accept the null hypothesis if X is more than 14, otherwise he will reject it. So we need to find alpha and beta. Alpha means type 1 error, beta means type 2 error. So by looking at the situation, right, the observed number is success, means recovery. So it should contain success and failure, mean recovery and not recover. So it has 20 trials, right? And you also have the probability of success, which is 0.9, right? So this is what we call a binomial problem, right? We have two outcomes and trial and probability of success 0.9. Theta equal to 0.9. So if you want to find the probability of type 1 error and type 2 error, let put the hypothesis statement first. Hypothesis, which is we have null hypothesis theta 1, theta equal to 0.90, right? And alternative hypothesis theta is equal to 0.60, right? And we also know we have n equal to 20. Our decision criteria, we're going to reject null hypothesis if x is less than or equal to 14. Right? Dia kata dekat sini, he will accept null hypothesis when x is more than 14. So we accept null hypothesis if x is more than 14. Right? So solution, if you want to find type 1 error, right? So alpha is equal to probability of reject. Sorry, I tulis betul-betul. Reject null hypothesis when null hypothesis is true. So this is the probability of type 1 error. So let's look at the definition again. So type 1 error is null hypothesis is rejected when null hypothesis is true, right? So this one. So probability of rejecting null hypothesis is when x is less than or equal to 14, right? So this is the decision criteria. When null hypothesis is true, so null hypothesis is true, theta is equal to 0.9. Theta equal to 0.90. So we already know this distribution is based on binomial distribution. So probability of x equal to 0 plus probability of x equal to 1 plus until probability of x equal to 14, right? So this is the probability that we want to find. So we can find it using manual calculation or using table. Let's look at how to use manual calculation. So we have 20 trial, right? 20, choose 0, and then the probability of success 0.9, power of 0, and probability of failure 0.1, power of 20 minus 0, 20, right? Plus until the 14, 20, choose 14, right? 0.9, this is 14, 0.1, 20 minus 14 is equal to 6. So this one should be equal to 0.0113, right? So this is, we are using manual calculation. If you are looking for using a table, we know that our n is equal to 20, right? So in our statistical table, it gives us the value on the right hand side, right? On the right hand side. So when we have 20 trial, this is when the probability of rejecting null hypothesis is until 14. So balance kita ada 6 saja kan. So using table, right? So we will use probability of x more than or equal to 6, right? When the probability equal to 0.1. So because we are reading the table to the right hand side, right? So this one should be 0.0113, same value, right? So this is how we find the probability of type 1 error or alpha, right? So now let's look at how to find beta. So it's the same concept. So beta is the probability of accept null hypothesis when null hypothesis is true. So is false. Null hypothesis is false. So it means that if we want to accept null hypothesis when x is more than 14, so probability of x more than 14, right? And theta is equal to null hypothesis is false, theta is equal to, this is false, theta should be 0.6, 0.60. So to find this one, you can use a manual calculation again, or you can use a table, right? Let's look at how to use table, right? This one should be probability of x more than or equal to 15, right? Theta equal to 0.6, right? So this one should be probability of x equal to 15 plus probability of x equal to 16 plus until probability of x equal to 20, right? So this one should be 20 choose 15, right? 0.6, 0.1, and 0.4. This is 20 minus 15. This is 15 actually. This is 5, right? Plus until 20 lah. 20 choose 20, 0.6, 20, 0.4, 0. So this one should be equal to 0.1256. Right. So far, do you have any question? Can you understand how we find alpha and beta, probability of type 1 error and type 2 error, right? So now we move to the next example, so you can understand the trend. So the trend should be very easy, right? Now look at example number 2. For Jones political pool n equal to 15 voter hours sample, we wish to test null hypothesis p equal to 0.5 and alternative hypothesis p less than 0.5. The test statistic is y, the number of sample voter favoring Jones. So we need to calculate alpha. If we select rejection region, y is less than or equal to 2 as a rejection region. Rejection region, so if you still remember, let's say I'm drawing a normal distribution. Let's say this is a rejection region, right? Y equal to 2. So this is a rejection region. This is a acceptance region. Now, by looking at this one, this example, right? We know that whether we have two outcomes, whether it's favoring Jones or not favoring Jones, right? So we have two outcomes, and then we have n trial, which is n equal to 15, right? And we also have a probability of success, which is 0.5. So if you want to find alpha, which is probability of type 1 error, this is a probability type 1 error, right? This is also equal to probability of reject null hypothesis when null hypothesis is true, right? So the rejection region is when y is less than or equal to 2. So probability of y less than or equal to 2 and null hypothesis is true. P is equal to 0.5. So this is null hypothesis P is equal to 0.5. Alternative hypothesis is equal to P is less than 0.5. So this is very simple. We can use, we can calculate straight away from a manual calculation, right? This is 15. We have 15 sample, choose 0. Let me put this way lah. We we have probability of y equal to 0 plus probability of y equal to 1 plus probability of y equal to 2. Right? So this one should be 15 choose 0, and this is 0.5 power of 15, 0.5 power of 0.5 power of 0, and 0.5 power of 15. Sama sajalah. Right, you see 15 power choose 1, 0.5 power of 1, 0.5 power of 14. The next one, 15 choose 2, right? 0.5 power of 2, 0.5 power of 13, right? So this one is going to lead us to 0.004, right? This is how we calculate probability of type 1 error, right? You can see the trend is always the same, right? It's going to repeat the same procedure all the time. Kalau 20 and 50 macam mana nak kira calculator, I don't understand. Apa soalan you sebenarnya? I tak faham. Can you voice out? Lagi senang. Dalam example 1, kurungan. Mana? This one. 20 choose 15. Right? Because we have x starting from 15. Right? You kira je lah. Macam biasa. Apa soalan you sebenarnya? I tak faham. You need to calculate by one lah. Or you can use statistical table lah. Macam tadi I tunjuk dekat you. Statistical table. But statistical table, you can twist sikit lah. You can twist sikit. Macam mana nak guna statistical table. Right. Let's say we have n equal to 20, right? This one. N equal to 20. Right. So 0.6 tak ada dalam table, right? Is it? 0.6 tak ada dalam table kan? You can twist sikit, so dia akan jadi probability of failure. Kita guna probability of failure. Right, so this one should be probability of x less than or equal to 5. Right? And then this one, theta is equal to 0.4, n equal to 20, right? Kalau this one, dia akan jadi 1 minus probability of x more than or equal to 6, theta is equal to 4, 0.4, n equal to 20. So, you can straight away calculate from a statistical table, then you akan dapat result yang sama lah, right? So, I hope you understand how to use statistical table. You are very clear how to use statistical table. If not, then you need to revise back your knowledge on using statistical table. Right. Right. Now, example number 3. Suppose we want to find the probability of committing a type 2 error in a gasoline experiment if the true mu with the additive were 25.750. Right. So this one, we have basically soalan ni tak habis, kan? We should have n equal to 30. This is soalan daripada they continue from previous example, right? And then we have sigma is equal to 2.4. This is from a previous example, right? And the null hypothesis, the alternative hypothesis here is mu. This is the alternative hypothesis. Mu is 25.750. Right? Sorry, this is a null hypothesis. Sorry. Null hypothesis is mu is equal to 25.750. Now, if you want to find probability of type 2 error, which is beta, is a probability of type 2 error, right? So probability of type 2 error is we accept null hypothesis. This is type 2 error, right? Okay, this is a null alternative hypothesis, yeah, correct. So we probability of accept null hypothesis when null hypothesis is false, right? The type 2 error. Okay, so now the true mean, this is actually y bar. I think soalan ni tak cukup complete, right? Dia tak bagi kat kita rejection region, right? So I bagi rejection region dekat you, rejection region. Rejection region y bar is more than 25.718, right? So this is a rejection region. So if you want to accept, so decision criteria, accept null hypothesis if y bar is less than 25.718. So we reject null hypothesis if y bar is more than 25.718. So soalan dia macam ni lah, tak cukup complete soalan ni, tapi I bagi dekat you the yang incomplete punya note lah, right? The incomplete value yang dia tak bagi dalam soalan ni adalah n is equal to 30, sigma is equal to 2.4, and rejection region y bar more than 25.718. Right, so this is the decision criteria. So accept null hypothesis when y bar less than 25.718, 25. And when null hypothesis is false, mu is equal to, this is alternative hypothesis, mu is equal to 25.750, right? So basically apa yang nak sebut kat sini, this quick example, statement dia tak complete, right? Dia ada soalan sebelum ni yang I tak tulis, right? This based, because this is based on the previous example. So this is basically normal distribution lah, right? So nanti kita tengok yang soalan lain pula. Just nak tunjuk dekat you, this is a normal, from a normal distribution. So normal distribution Z should be equal to y bar minus mu divided by sigma over square root of n, right? So this one should be 25.718 minus 25.750 divided by sigma is equal to 2.4 over square root of 30, right? So this one, if you look at into a statistical table, you will get 0.4721. So this is the probability of type 2 error. Right. Now, Let's look at another example, then we will revise back your understanding, right? So don't worry, I prepared a lot of example for this subtopic for you to understand thoroughly, right? So we need to refer to example number 2. Example number 2 is Jones political pool. So in example number 2, it says that we have n equal to 15, right? And current probability of null hypothesis is P is 0.5. And alternative hypothesis is P less than 0.5. And the rejection region is Y less than 2. Right. This is the information that we have from example number 2. Right. Now, refer to example number 2. Is our test equally good protecting us from conducting that Jones is the winner? In fact, he will lose the pool, right? Suppose that he will receive 30% of the votes, which is P equal to 0.3, right? Instead of 0.5, dia akan dapat 0.3%. 30% lah, 0.3. So what is the probability of beta, probability of type 2 error, that sample will erroneously lead us to conclude null hypothesis is true, that John is going to win. So we want to calculate the probability of type 2 error. Probability of type 2 error is beta. This is probability of type 2 error, right? Probability of type 2 error is equal to probability of accept null hypothesis when null hypothesis is false, right? This is our definition. So the value of test hypothesis is not rejecting region when H null hypothesis, alternative hypothesis is true is 0.3, right? So this is the claim that he will receive 30% of the vote. Means this is the alternative hypothesis. P is equal to 0.3, right? And null hypothesis should be more than or 0.5 or any value lah. Dia tak bagi dekat sini, right? So dia hanya bagi dekat kita the alternative hypothesis, right? So we know that P is equal to 0.3. So we also know this problem came from a binomial problem based on example number 2, right? So probability of beta, right? Beta is the rejection region. Our rejection region is based on example number 2, right? This is 2 when we reject null hypothesis, right? This is more than 2 when we accept null hypothesis. So our condition now is we accept null hypothesis. Probability of Y more than 2. When probability of success is 0.3, right? So we can use calculator or you can use statistical table, right? I think better use calculator, senang sikit. Summation of when Y equal to 3 until 15. How do we know 15? Because based on example number 2, we only have n equal to 15, right? So this is the summation, the cumulative probability value lah. So 15 choose Y, and then 0.3 power of Y, 0.7 power of n minus Y. So you input this formula into your calculator, you will get 0.873. So this is the probability of committing type 2 error, right? So the value is quite high, so means that 0.3 tu mungkin salah lah. So instead kita boleh conclude dekat sini, Jones will win, right? Jones will win. So far we already done example 1, 2, 3 and 4. Can you see the pattern, right? How we calculate type 1 error and type 2 error? Do you understand or you have any question to ask? Ada soalan tak? Any question? Kau cakap seorang-seorang ni? Hello? Soalan? Voice out please.
Tak ada, sir.
Alright, good. So we shall continue on example number 5. Right. Now, look at example number 5. Suppose that we want to test a null hypothesis that the mean of normal population sigma square equal to 1. Right. And mu naught against the alternative hypothesis mu1, right, where mu1 is greater than mu naught. Find the value of k such that x bar is more than k, provide a critical region of size alpha equal to 0.05 for a random sample of a size n. So now, apa yang kita nak ni? Dalam soalan ni, dia nak suruh kita cari critical region. Right? Critical region adalah k. Kita tak tahu the value of k. Right. Tadi kita tengok example number 1 and example number 4, we are looking into alpha and beta. That one is very simple, straightforward. You just need to understand determine the distribution of the statement, and then we need to find the alpha and beta straight away. Very simple. Now, this problem is, instead of finding alpha or beta, they already give us the value of alpha, which is 0.05. Right. So now they want us to find the critical region. What is the critical region again? Critical region is the region that we reject null hypothesis, kan? So let's say this is a normal distribution, right? Negative alpha and negative infinity to infinity. So this is, let's say, k here. So apa-apa yang belakang daripada k, this is a rejection region. This is acceptance region. Right. So we want to find the value of k here. So now, so from the statistical table, right, we know if you look at the normal distribution, table number 4, table number 5, alpha 0.05, it should be equal to 1.645. So this is going to be your alpha, 0.05. If the value of k is more than 1.645, is our committing type 1 error. Right. So now by this value, right, we try to manipulate it. This one you should get from the z value. So this is a z value, right? This is from negative infinity, this is 0, this is infinity. So z value, k minus mu naught divided by sigma over square root of n. It should be equal to 1.645. So this is the value of z, right? This is z. This is the value of alpha, right? From here, you can find the value of k, right? Tapi this one kita tak tahu lagi sama ada dia duduk di sebelah kanan atau sebelah kiri, right? We really don't know whether the value of k here is locating on the right hand side or left hand side. So now, before we end up with our conclusion, we need to find whether k is on the right hand side or left hand side, right? So now, tapi macam mana pun dia dah bagi tahu dekat sini. Dalam example ni dia dah bagi tahu find the value of k such that x bar is more than k, provide the region of alpha less than 0.05. So this one clear cut lah, tak payah nak cari sebelah kanan sebelah kiri. We already know probability of x bar more than k is equal to 0.05, which is also equal to probability of Z more than K minus mu naught divided by Y mu naught sebab this is a probability of type 1 error, right? Alpha kan. So sigma over square root of n. Right. So this one should be probability of Z more than K minus mu naught. We don't know the value of mu naught. And sigma is equal to 1, right? This is 1 divided by square root of n. So from the table we know 0.05 should lead us to 1.645, right? Right. So this is the value of this one, right? This one should be 0.05. So now, if you losing the bracket of probability sign, so we will get K minus mu naught divided by 1 over square root of n equal to 1.645. So this one should be equal to, kita nak tinggalkan K kat sini, K should be equal to mu naught plus 1.645 divided by square root of n. So this is the value of K. This is our formula for critical region K. That's all. Alright. Now we move to the next example. Example number 6. Right. Example number 6, a random sample of size 8 is taken from a normal distribution with unknown mean mu and the variance sigma squared equal to 40. So given hypothesis statement, mu naught, null hypothesis mu is equal to 15, alternative hypothesis mu equal to 9. So let the critical region be C is equal to y bar less than 12.5. So if the following value are observed, we have 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8. So we have 8 observations. So we want to know what is our conclusion, what is our decision. So to make up our decision, right, we just need to base on the observation and the critical region, right? So based on the critical region, right, let me put the hypothesis statement. Right, null hypothesis mu is equal to 15, alternative hypothesis mu is equal to 9, right? So we know we will reject decision criteria. We're going to reject null hypothesis if y bar is less than 12.5, right? We're going to accept null hypothesis if y bar is more than 12.5. So now, given this value, we only have 8 observations. So we need to find y bar. So y bar is equal to 20 plus 19 plus 17 plus until 15 divided by 8. So this one should be equal to 16.125. So our decision is, since y bar is more than 12.5, alternative hypothesis is accepted. So that's how we made up our decision. This is for question number A, right? So for question B, they ask us to find the probability of type 1 error and the probability of type 2 error. So this is going to be very easy, right? So probability of type 1 error is alpha, right? So alpha is equal to probability of type 1 error, which is also equal to probability of reject null hypothesis when null hypothesis is true, right? So reject null hypothesis when y bar is more than 12.5. Probability of y bar more than 12.5 and mu is equal to null hypothesis is true, mu is equal to 15. Mu equal to 15. So this one, just plug in the value into the, sorry, this one wrong, huh? We reject null hypothesis when y bar is less than 12.5. So it should be less than. This one less than what 12.5. So just plug in the value into Z distribution. Z less than 12.5 minus 15 divided by our sigma is equal to 40. Sigma square is equal to 40. N is equal to 8. So this one should be square root of 40 over 8. So this one, probability of Z less than negative 1.18. By looking into the statistical table, it should be at 0.1314. So this is our probability of type 1 error. It's quite high, 0.13, right? So this is how we calculate the type 1 error lah. And the second question is, they ask us to find the probability of type 2 error. Probability of type 2 error is beta. Probability of type 2 error, which is equal to probability of accept null hypothesis when null hypothesis is false, right? So this is the probability of type 2 error. So to accept null hypothesis, the rejection region, the acceptance region is when y bar is more than 12. So probability of y bar more than 12.5, given that alternative hypothesis, null hypothesis is false. So we're going to accept alternative hypothesis, which is mu is equal to 9. Right? Mu is equal to 9. So this one should be probability of Z more than 12.5 minus 9 divided by square root of 40 over 8. So this one should be probability of Z more than 1.565. Looking at the statistical table, it should be 0.0582. So this is how we find probability of type 2 error. Right? Are you okay? Any question? Do you understand?
Yes, sir.
Right. Since you understand, I will give you 5 minutes lah. 5 minutes for you to answer the first question in example number 7. 5 minutes. Please answer example number 7A. So this is example number 7, like y1 until y5 denote a random sample from a population with mean equal to mu and variance equal to sigma square, and testing the null hypothesis, mu is equal to 1, alternative hypothesis mu equal to 2. The best critical region is y equal to k, y is more than k. So they already give us y more than k is the best critical region, right? Now, if the significant level is set to be 0.05 and sigma square is equal to 1, find the value of k. This is very simple. So you have 5 minutes to complete example number 7A. The value of K, which is our critical region, right? We are given alpha is equal to 0.05, and the best critical region is Y bar is equal to more than K, right? And our null hypothesis is mu equal to 1, and alternative hypothesis is mu equal to 2, right? We have 5 observation, right? 5 observation. So alpha is equal to probability of type 1 error. We start with our known information, which is our alpha, right? Probability of type 1 error is probability of reject null hypothesis when null hypothesis is true, right? So rejecting null hypothesis is probability of y bar more than k, and alternative null hypothesis is true, right? So mu is equal to 1. So this is equal to 0.05. So this is our alpha, right? So this one, probability of z more than k minus mu equal to 1 divided by sigma over square root of n equal to, this is probability of z more than k minus mu. Now mu is equal to 1 minus 1 divided by our sigma is equal to 1 as well. So 1 divided by square root of n. N is 5. So we have n equal to 5. So this is equal to 0.05. By looking at the statistical table, 0.05 is 1.645. Right. So we know here k minus 1 divided by 1 divided by square root of 5 is equal to square root of 5 equal to 1.645, right? So we do a mathematical manipulation here, should be equal to k equal to 1.7357, right? This is how we calculate the value of k. Right, now move to the next example. Let the sample above shows some value here. We have 5 value, 1.4, 1.3 until 1.5. What is our conclusion? Right? So B, so Y bar is equal to summation of Y I divided by N. So you need to plus everything, 1.4 plus 1.3 plus 1.9 until 1.5. It should be divided by 5, you should get 1.64. So since k is equal to 1.7357, right? So remember the rejection region, right? We accept null hypothesis if k is more than more than 1.7357. We reject null hypothesis if k is less than 1.7357. So since k is equal to 1.7357, right, which is more than wait. This is we accept when less than kan, more than kan. So since k is equal to 1.7 is more than sorry, I think terbalik dekat sini. We accept null hypothesis when k is less than 1.73. When K is more than 1.73, we will reject. So dia macam ni bentuk dia. Kalau you confuse, you always draw the distribution. So this is, let's say, 1.7357. So the critical region, and the critical region is Y more than K. So this is more than K. This is rejection region, and this is acceptance region. Right. So when the value of Y bar is less than K, this is K, we're going to accept null hypothesis. When it's more than K, we are going to reject null hypothesis. So since it's less than 1.7, we will reject null hypothesis, right? So this is how we accept dah. Kita accept lah kan, less than 1.7 kan. This is accept, right? Baru betul. Okay, boleh faham? Kalau dia kurang daripada 1.7, kita akan accept null hypothesis. Kalau dia lebih daripada 1.7, kita akan reject null hypothesis. So since Y bar is 1.6, less than 1.7, we will accept null hypothesis. So our decision is to accept null hypothesis lah, right? Ya, dia memang tak cakap sebab this is the critical region. Yep. This is the best critical region. When the critical region means kalau dia lebih besar daripada K tu, maksudnya kita akan reject null hypothesis. Kalau dia kecil, kita akan accept null hypothesis. That's the rule lah. Right? So now, look at the next question is, what is the power of the test? C. C, we want to find the power of the test. So power of the test, okay, C. Power of the test is equal to 1 minus beta. Right, this is power of the test. Macam tadi saya beritahu dekat you, beta is the probability of type 2 error. Power of the test is 1 minus beta. So from here, we know that we don't really know the value of probability of type 2 error. We need to find the probability of type 2 error. So probability of type 2 error is probability of accept null hypothesis when null hypothesis is false, right? So probability of Y bar is less than K. So the condition of accepting hypothesis is when Y bar is less than K, right? Alternative hypothesis is null hypothesis is false. So alternative null hypothesis is mu is equal to 1. Alternative hypothesis is mu equal to 2. So mu is equal to 2, right? So we know from the previous example, K is equal to 1.7357, right? So now we just plug in the value into the formula. Probability of Z less than 1.7357 minus mu which is equal to 2, right? Minus 2 divided by sigma. Our sigma is equal to 1, right? 1 over square root of n. N is equal to 5. We have 5 value. So n5. So this one should be probability of Z less than negative 0.59. So just look into the table. We will get 0.2776. Right. Now, we already know the value of type 2 error. To find type 1 power of the study, power of the test, power of the test. So this is our beta. 1 minus beta. So 1 minus 0.2776. This is equal to 0.7224. Right. Okay. Now, for the last example, the last question, if it is required that alpha remains 0.5, but the beta should be reduced to 0.1. Right? Find the critical value and the sample size need to be taken. Now, apa yang dia cakap dekat sini, our alpha current our current alpha is 0.05, but our beta is 0.2776. The question asks us, we want to reduce the value of beta. So alpha remains 0.05, but beta, instead of 0.776, we want it to be 0.1. So now we want to determine how many sample size and what is the critical region that we need to set so that the probability of type 2 error is 0.1. Right. So this is going to be very tricky. Right. So I bawa panjang sikit. So now, let me use the first color is green. Let's say we calculate for alpha dulu. Alpha is probability of type 1 error, which is equal to 0.05, right? Which is also equal to probability of reject null hypothesis when null hypothesis is true, right? So 0.05 here. So y bar more than k and mu equal to 1. So remember tadi, null hypothesis, mu equal to 1. Alternative hypothesis, mu is equal to 2. Right, this is from the statement. Right, so now, the best critical region here should be probability of z more than k minus mu divided by sigma over square root of n, which is equal to 0.05. And we plug in the value of mu and sigma here. So kita padam ni, mu is equal to 1, sigma also equal to 1. Right? So we know that when alpha is 0.05, this value should be 1.645. This is from statistical table. Right. So this one, 1.645 equal to k minus 1 divided by 1 divided by square root of n. So k here should be equal to 1 plus 1.645 over square root of n. So this is our first equation. Because we want to find n and k, right? So now, we want, next step, we're going to reduce beta equal to 0.1. So let's say beta equal to 0.1. This is a probability of accepting null hypothesis, accept null hypothesis when null hypothesis is false, right? So probability of accepting null hypothesis. So this is rejecting null hypothesis. The current critical region, y bar is less than k. So then we can accept null hypothesis, mu is equal to 2. So this is 0.1. Right. By looking at the statistical table, 0.1 should be equal to 1.28. Right. So since this value on the left hand side, it should be lies on it should be on the left hand side lah. It should be negative 1.28, right? So this one should be Z K minus mu over sigma over square root of N. This is probability of Z less than K minus 2 because mu is equal to 2 and 1 sigma over square N. So this one, kalau kita ambil this one saja, negative 1.28 equal to K minus 2 over 1 over square N. Right? So then it will let us K is equal to negative 1.28 divided by square root of N plus 2. So this is going to be second equation. So we have first equation and second equation, right? How to solve this one? You can put 1 into 2 or 2 into 1 is the same, right? Put 1 into 2, right? So 1 plus 1.645 divided by square root of N equal to negative 1.28 divided by square root of N plus 2, right? When we solve this one, you should get square root of N equal to 2.925. N should be equal to 9. N of course equal to 8 point something lah. 8.5556. So equivalent to 9. So sample size always round up. So now we already find the value of N, right? So if you want to find the value of K, you just substitute the value of N into K lah, since N is equal to 9, right? Using, you can use one or two, first equation or second equation. So let me use second equation. K is equal to negative 1.28 divided by square root of N plus 2. So K should be equal to 1.28 divided by square root of 9 plus 2. So K should be 1.57333. Right, that's how we answer the question lah. Okay, any question? Question? Or any part you don't understand, you can raise the question now. And don't forget to sign in your attendance, yeah? So far, soalan? So I have more example until example number 14. I think I'm very tired right now. Banyak sangat I cakap, I tunjuk dekat you. So why not you try example number 8 now. Right? I just want to see whether you can do it or you cannot do it. So we have example 8 until 14. Right. Example number 8, 9, 10, I leave it for group A to do. For example number 11, 12, 13, and 14, I leave it for group B to do. Right? And of course, you need to do both lah. Right? But we have another half an hour. Right? I will randomly pick one of you to answer example number 8 until example number 14. Are you ready? No? Ready or not ready? Okay, fine. Try to do example number 8 first before I can let you go. Right? I will pick randomly and you need to present to me. Right? So I give you 10 minutes to complete example number 8. Alright? Starting now lah. So now let Z1 until Z30 be a random sample of size 30 from a distribution with N, distribution N, phi 4. and test null hypothesis state phi is equal to 1 and alternative hypothesis phi is equal to 0 and z bar is less than c is our critical region. Right, so find C so that the significant level is 0.05. So now, dia dah bagi tahu kat kita, the probability of type 1 error is 0.05. This is the probability of type 1 error. Right? You boleh nampak? Right? So now, they also give a Z distribution, Z bar distribution is having normal distribution with phi mean equal to phi and standard error is equal to 4 over 30, right? 4 over square root of 30. Okay, so this is a standard error. So now, probability of type 1 error is a probability of reject null hypothesis when null hypothesis is true, right? So probability of Z less than C. Z bar less than C is rejecting null hypothesis. When null hypothesis is true, phi is equal to 1. Right. So now 0.05 equal to probability of Z bar less than C minus phi over sigma over square root of n. Right. So this value is 0.05 equal to 1.645. So this one should be on the left hand side, right? So 0.05 here, which is our alpha. This is negative 1.645. And this is 0. And this is infinity to negative infinity. Right? So negative 1.645 is equal to C minus phi divided by sigma over square root of n. So we know that from the statement sigma is equal to 2 because this is the value of variance, right? This is value of variance. Sigma is equal to 2 and phi is equal to 1, n equal to 30, right? You just plug in the value 1.645 C minus 1 divided by 2 over square root of 30. So this one should be C is equal to 0.3995, right? Then for B, if you want to compute the power of this test, if alternative hypothesis is true, use C obtained in A, right? So first we need to find the probability of type 2 error, beta, probability of type 2 error, right? So which is equal to probability of accept null hypothesis when null hypothesis is false, right? So accept null hypothesis when Z bar is more than C and phi is equal to 0. This is for alternative hypothesis. So probability of Z more than C minus phi divided by sigma over square root of n. So this is probability of Z more than 0.3995 minus 0. Wait, right. Sorry about that. So this one divide by 2 over square root of 30. So this one should be equal to probability of Z more than 1.09, which is equal to 0.1379, right? So this is the value of beta, which is probability of type 2 error. To find power of the test, which is equal to 1 minus beta, 1 minus 0.1379 should be 0.8621. Right, so that's how we answer the question. So later on, I will put example number 9, 10, 11, and until 14 into a Google Classroom. Right, make sure you can you make it this one as your homework. Make sure you do it by yourself. If you stuck, you can you can discuss among you. You can do a Google Meet among you, right, to discuss this one, because Google Meet currently is already free, kan? So if you stuck with your friend, then you can ask me a question, right? Okay, ada soalan tak setakat ni? Right, so tomorrow, next week lah. Tomorrow I akan premiere balik video ni. I will try to premiere back this video. So next week we will try to finish up our chapter number 3, which is Neman Personal Lemma, our last topic for chapter number 3. And then it should be ready for assessment number 2. Assessment number 3. Right? Last test one is assessment number 2. Next one is assessment number 3. And then you should have assessment number 1 nanti ada quiz 1, 2, 3, right, which is assessment number 1. And the last assessment should be chapter number 4. Right? Okay? Can you voice out? I tak dengar suara lah. Macam I cakap seorang-seorang.
Okay, sir.